Namaste, welcome to Group 1 Services Mains Orientation telecasted by Tsat. Everyone knows that so in paper 5 we have data interpretation and problem solving. In this we have number sequence and different kinds of number series like arithmetic progression, geometric progression, harmonic progression, arithmetic geometric progression, Fibonacci series, triangular numbers, square numbers, happy numbers, sad numbers, like there are n number of kinds of numbers are there. So, you can play with numbers, that is the beauty of the numbers, correct. So, means in point of examination, we can give a lot of logic also in this examination purpose in point of view, correct. So, now we are going to discuss all these different kinds of numbers. Today we are going to play with numbers. So, how the number questions, number sequence or number series questions comes in the examination, what are the different kinds of number sequences and what are its applications in the present system, we are going to discuss it. Okay. Now, see here one question is there, what will be the 15th term of arithmetic sequence minus 3 minus 1 by 2 using sequence and series formula. This is the question is given here. What will be the 15th term of arithmetic sequence? Before going to discuss, you have to understand what is an arithmetic sequence. Means if a sequence or the numbers are increased or generated by adding some number, that sequence is called arithmetic sequence. Is it clear? Okay. So, simply we will say in arithmetic sequence the nth term an is equal to a plus n minus 1 of d. This is the formula. Here a is the first term, n is the number of terms and d is the common difference. How we are going to find the common difference? You can find the common difference d by difference of two successive terms. Means second term means T2 minus T1 gives D. So, what is T2 here? Minus 1 by 2. Minus 1 by 2 is T2 minus, what is the first term here? Minus 3. So, you will get minus 2 of minus 3 means minus 1 by 2 plus 3. 3 2 is 6, 6 minus 1 is 5. So, 5 by 2 is a common difference. Okay. So, we know the value A, that is A is how much? Minus 3. We know the value of D 5 by 2. What is required here? 15th term is means T15 is required. N is equal to 15. So, we know all the information when required formula. So, in this A is 3 minus 3, D is 5 by 2, correct, N is 15 and the formula Tn is T15 equal to A plus N minus 1 of D. This is the formula. So, now we have to substitute the value, that is minus 3 plus N is 15, 15 minus 1, D is 5 by 2 means minus 3 plus 15 minus 1 is 14, 14 of 5 by 2, 2 1s are 2 7s, minus 3 plus 35, 35 minus 3 is 32. So, answer is 32. See, means when you know the formula, you can find the answer a very simple manner, clear. So, this is a very important, like you can find the required answer. So, very important thing is in this, especially in the number system, you have to understand the pattern, you have to understand the rule and you have to understand or you have to recall the formula, especially the concerned formula for the given problem, clear. Okay. Now, we will see the next. The fourth term in an arithmetic sequence is minus 20 and the 8th term is minus 10. Then what is the 100th term in this sequence? This is the question. The fourth term in arithmetic sequence is minus 20. So, means here T4 equal to minus 20. fourth term is minus 20 and eighth term is minus 10. Eighth term T8 minus 10. Actually, what is the formula? Tn is equal to A plus n minus 1 of D, correct? Now you have to find the T fourth term, T4. T4 is equal to how much? A plus n is 4 or no? 4 minus 1 of D, which is equal to minus 20 is given. Or you can say A plus 3D equal to minus 20. Say this is equation 1. Next, T8. T8 means A plus 8 minus 1 of D, means A plus 7D. It is given as minus 10. So, A plus 7D is equal to minus 10. A plus 3D equal to minus 20. A plus 7D equal to minus. Say this is equation number 2. Means simple linear equations. Solve these two simple linear equations. Means A plus 3D equal to minus 20. A plus 7D equal to minus 10. So, simple linear means subtract these two equations. So, minus plus. So, A and A get cancelled. 3D minus 7D is minus 4D and minus 20 plus 10 is minus 10. So, D is equal to how much? Minus 10 by minus 4, minus 1 get cancelled, 2 5s are 2 2s are, means D value is 5 by 2. Clear? Okay. Now, we can find the 100th term. If you want to find the 100th term, what is required? The A value is required. Now, you have equation A plus 3D is minus 20. Now, you have to substitute that value. A plus 3D, 3D is 5 by 2. 5 by 2 is equal to minus 20. A plus means 15 by 2 equal to minus 20. Or A equal to how much? Minus 20. Send it to other side, minus 15 by 2. Means minus 20 minus 40 minus 15. Minus 55 by 2 is the value. Okay. Minus 55, but is the A value. Now, we are going to find the value of 100th term. Means T100 is required. What is T100? A plus 100 minus 1 of D. A is how much? Minus 55 by 2 plus 100 minus 1 is 99 and D is how much? 5 by 2. Okay. Minus 55 by 2 plus 99 5s means 495. Correct? 495 by 2. It means 2 is a LCM, means 495 minus 55 means is 440 by 2, means 2 1s are 2, 2 20s means 220 is the 100th term in this sequence. See, like you can find the answer. In this way, you can find the which term is required, you can find. You can find the number of the term also. You can find the sum of the terms also. Like the questions may come in the examination, we will discuss some more on this particular area. So, that is an arithmetic progression area. Okay. Are you understand? That is an arithmetic progression. In arithmetic progression, you have to remember the important concept is the sequence is either increased or decreased by adding or subtracting a fixed number. That number is said to be a common difference. So, and the nth term of this series is an equal to a plus n minus 1 of D, or L is equal to a plus n minus 1 of D, and sum of terms Sn is equal to n by 2 of 2a plus n minus 1 into D, or n by 2 of a plus L. These are the two formulas which are useful to calculate the number of the terms and at the same time sum of n terms also. Is it clear? Now, we will shift to the geometric series, next series. So, we will practice the questions, different questions on this particular area, but we are shifting to the next one, and the geometric series. So, geometric series means actually in social studies generally everyone knows it, one of the greatest social reformer, he says that said the food grains are increasing in arithmetic progression, but the population in the world are increasing in geometric progression. That's the reason we are suffering with poverty, because arithmetic progression increasing slowly, but geometric progression increases rapidly. The population is increasing rapidly, but there is no increase in the land. Correct or not? So, increasing the quality and of the or quantity, especially the quantity of the food grains will be not raised. How the percentage of increase in the population is not equal to the percentage of increase in the production of food grains. That's the reason he said simply the food grains are increasing in arithmetic progression and the population is increasing in geometric progression. Then what is geometric progression? Just now see. The geometric series is a number series where the following or next number is obtained by multiplying the previous number by a constant known as a common ratio. Okay, now we will say, I will say, for example, if you say 2, 6, 18, 54, what is the next number? Means 6 by 2 is 3, 18 by 6 is 3, 54 by 18 is 3, or 2 3s are 6, 6 3s are 18, 18 3s are 54. So, what the next number 54 3s are? 162. So, the next number is 162. Is it clear? Means here the next number is generated by multiplying with a fixed number. That number is said to be here a common ratio. In arithmetic progression, that is called common difference. Here we will call it as a common ratio. Are you understand here? So, the number is generated by multiplying a fixed number. And the nth term here, nth term an is equal to a of r to the power of n minus 1. R is the common ratio, n is the number of the term. So, an equal to nth term and a1 is the first term and r a is the first term and r is the common ratio. So, this is about nth term of a geometric progression. Okay. So, and one more important, if you take 2, 6, 18. So, these are in geometric progression, we will GP. 2 8s 36, correct? Means 6 square is equal to 2 of 18. Am I correct? So, if A, B, C are 3 numbers which are in GP, then B square equal to AC. Here the B is called geometric mean, or B is equal to root AC. B is called geometric mean GM. So, geometric mean of the 3 numbers A, B, C which are in geometric progression, B equal to under root AC. This is our one more important relation. Okay. Now, we will see this example 1, 3, 9, 27, 81, 243. When you multiply 1 by 3, you will get 3. When you multiply 3 by 3, you will get 9. When you multiply 9 by 3, you will get 27. When you multiply 27 by 3, you will get 81. When you multiply 81 by 3, you will get 243. So, here 3 is called a common ratio. The next number will be generated by multiplying with a fixed number which is called a common ratio. This pattern is called geometric progression, geometric sequence or GP. Clear? Okay. Now, we will see the term, terminology and the formulas of arithmetic progression here. So, here A, AR square, AR cube and so on, AR to the power of n minus 1 which are in geometric progression. Clear? And the next one is geometric series a plus ar plus ar square plus 1 up to ar to the power of n minus 1. This is a geometric series. Clear? So, now I will say, for example, 2, 4, 8, 16, 32, 64 and so on. This is a geometric progression, correct? And here the first term is 2. Of course, the common ratio also 2. Then how you are going to get the common ratio? Divide the first term by, divide the second term by the first term, then you will get common ratio. Okay. Now, for example, you want to get third term, T3. So, 8, correct? Which is 9, you can write 2 of 2 square, or you can write 2 of 2 to the power of 3 minus 1. Here 2 is A, of course 2 is R, 3 is third term, so n minus 1. So, this is the nth term of an arithmetic progression. Okay. But here there are two kinds of series in the geometric series, maybe finite, maybe infinite. Okay. So, if the R value is more than 1, then the sum of n terms Sn is equal to A of R to the power of n minus 1 by R minus 1. The condition R is not equal to 1 and R is greater than 1. The condition is the sum of n terms of a geometric progression is A of R to the power of n minus 1 by R minus 1. The condition is R greater than 1 and R is not equal to 1 when it is a finite series. For example, if R is less than 1, then there is a possibility to change. There is a possibility to change. When R is less than 1, it is the possibility to change or continue for the infinite terms. Infinite terms. So, at the time means R is less than 1 means infinite term. So, simply we can call it as Sn is equal to E of 1 minus R to the power of n by 1 minus R. This is a very important information. So, Sn is equal to A of R to the power of n minus 1 by R minus 1 is the sum of n terms of a geometric progression where R is greater than 1 and R is not equal to 1. And the sum of n terms of a geometric progression Sn is equal to A of 1 minus R power n by 1 minus R where R is less than 1. So, when R is less than 1, you have to write A of 1 minus R power n by 1 minus R. When R is greater than 1, you have to write Sn is equal to A of R to the power of n minus 1 by R minus. Is it clear? This is a very important information. We will see some questions here. Find the sum of the infinite geometric series minus 1 plus 1 by 2 minus 1 by 4 plus 1 by 8 minus, already you know that. So, when R value is less than 1. So, how you are going to get R value here? R is equal to 1 by 2 by minus 1 means it is minus 1 by 2. Very clear, you know that R is less than 1. Okay, negative value. Then the sum of this series is S infinity is equal to A by 1 minus R is the formula. So, A by, what is A here? A value, the first term A equal to minus 1. Minus 1 minus, what is R value calculated? Minus 1 by 2 means minus 1 by 1 minus of minus plus by 2. 1 plus 1 by 2, that is minus 1 by 3 by 2, or you can say it is minus 2 by 3. Understand? So, S infinity is equal to minus 2 by 3. Like you can find the sum of infinite geometric series. This is a one more formula you are going to learn, that is sum of infinite terms or sum of terms in the infinite series is S infinity is equal to A by 1 minus R, and very important one is when modulus R is less than 1, there is a possibility for infinite series and its sum is A by 1 minus R. This is very, very important. Okay. What is the sum of the first 10 terms of the geometric sequence 5, 15, 45? So, maybe here due to number of sessions and lack of time, we are not giving a totally comprehensively discussion on this one, but we are giving the cream essence of the particular concept. So, I hope all the aspirants are understand this area, because we want to give the information very clear and crispy, very simple. At the same time, we have to cover the total information. Of course, we are not giving more practice on this particular concept, but you have to practice by taking different books and based on this area. Okay. So, what is the sum of the first 10 terms of the geometric sequence of 5, 15, 45? So, here, so A equal to 15, correct? Sorry, A equal to 5 and R equal to 15 by 5, which is 3. What is required here? Sum A means sum S10 is required. What is the formula? Sn is equal to A of R to the power of n minus 1 by R minus 1 is the formula. So, now we will going to, because R is greater than 1, correct? Okay. So, S10 A is 5, R to the power of means 3 to the power of n is 10 minus 1 by R minus 1, 3 minus 1 means 5 by 2 of 3 power 10 minus 1. This is the value. You can calculate it what is 3 power 10 minus 1, but the value is simply 5 by 2 of 3 power 10 minus 1. Are you understand? So, sum of n terms in infinite series A by 1 minus R, but sum of n terms in a series where R is greater than 1, the formula is A of R power n minus 1 by R minus 1. You have to follow this. Okay. Now, we will compare these two progressions, arithmetic progression and a geometric progression. Of course, this is AP and this one is GP. Okay. Now, what is sequence here? Generally, you can say A plus D, A plus 2D, A plus n minus 1D, n minus 1 of D. Here, AR square, AR to the power of n minus 1 and so on. That is a sequence. Okay. For example, there are 3 terms which are in AP. Then how we are going to assume it? That we can assume as A minus D, A plus D. Because when you add all this, so A will get value. That is very, very important. When 5 terms are there, you can add it as A minus 2D, A minus D, A plus 2D, okay, A plus D and A plus 2D. So, like you can say, you can assume it. If, for example, if you want to generate AR square, AR cube, that is a geometric progression. Now, common difference. So, here the difference between any two consecutive numbers, successive numbers in the arithmetic progression is called the common difference. Means A2 minus A1 gives D, or AN minus AN minus 1 gives D. Is it clear? That is a common difference. And common ratio, in geometric progression we call it as a common ratio. Common ratio means it is a ratio of preceding term and successive term. means if A1, A2, A3 and so on, that's a geometric progression, then A2 by A1, here R is equal to A2 by A1, here D is equal to A2 minus A1. That's the difference between arithmetic progression and geometric progression. Are you understand this one? Don't get any kind of confusion. Very simple. Here common difference, there we are using common ratio. That's the first thing. And here common difference, that's the reason we will say A2 minus A1. That's a common ratio, we will take the ratio of A2 and A1. Clear? And the general term, when you take the general term is an is equal to a plus n minus 1 of d. That's the general term. Of course, we call it as Tn also. Sometimes we call it as the last term L also. So, L is equal to a plus n minus 1 of d, or an is equal to a plus n minus 1 of d. This is the general term of an arithmetic progression. Here a is the first term, d is the common difference, n is the number of terms. Is clear? When you come into the geometric progression, so nth term an is equal to a of r to the power of n minus 1. Here a is the first term, r is the common ratio and n is the number of. That's the difference between or comparison between the general term of arithmetic progression and geometric progression. Okay. Now coming to the nth term or the last term. So already I said nth term or last term will be same. And sum of first n terms, that's a very important. Sum of n terms means here Sn is equal to, that is n by 2 of 2a plus n minus 1 into d. This is sum of n terms, or you can say Sn is equal to n by 2 of a plus L, where a is the first term, L is the last term and n is the number of terms. Nothing difference between the previous formula, that is Sn is equal to n by 2 of 2a plus n minus 1 into d. Sn, because the last term L is equal to a plus n minus 1 into d. When you substitute the L value, then you will get the first term. Understand? Similar manner, the sum of n terms of an arithmetic progression, the sum of n terms of an arithmetic progression is Sn is equal to n by 2 of a plus n minus 1 into d. Okay, 2a plus n minus 1 into d. Whereas in geometric progression, its value Sn is equal to a of r to the power of n minus 1 by r minus 1. Here very condition, what is the condition here? If modulus r is greater than 1. Modulus r is greater than 1. If r is, common ratio is more than 1, that's very important. Otherwise, Sn is equal to a of 1 minus r to the power of n by 1 minus r. So, here modulus r is less than 1, that's the condition. And if the series tends to infinite, the sum of n terms of sum of terms in the infinite series, S infinity is equal to a by 1 minus r. This is the different formulas in geometric progression. And one more here, arithmetic mean, when three quantities a, b, c are given, arithmetic mean b is equal to a plus c by 2, b is called arithmetic mean, and the geometric mean is equal to b is equal to under root ac. If there are n quantities, the arithmetic mean is a1 plus a2 plus a3 plus so on up to an by n. This is arithmetic mean, and the geometric mean is nth root of a1, a1, a2, a3, a1, a2, a3, an. Clear? Okay. Like you can say the formula. Okay. So, now we discuss about arithmetic progression and geometric progression. We have some more progressions and some more sequences. We will discuss all those things in the next episodes. Until Namaste.